Let's start off with the next type of integration, which is very important. That is root of quadratic. That is root of a square minus x square, root of x square plus a square, or root of x square minus a square. So there are three formulas for this, and you can easily derive the formulas using the UV rule. So let's start off with one of them. So let's start off with the first one. That is integration of root of a square minus x square dx. Let's see if I have to derive the formula, how will we do that? So let's start off with the UV rule. So I'll just multiply this by 1, right? So I'll consider this as u and this as v. So let's start off with this. So when you integrate, you'll have, so this is I is equal to, right? So I is your question. So I is equal to, so let's apply the UV rule. So you have root of a square minus x square integration of 1 dx minus integration of derivative of root of a square minus x square into integration of 1 dx the whole dx. So this is using UV rule. Now integration of 1, this one. Integration of 1 is x. So x into root of a square minus x square minus integration sign is outside. Derivative of this. So derivative is 1 upon 2 root a square minus x square. By chain rule, derivative of minus x square is minus 2x. So this 2 gets cancelled into integration of 1, which is x, into dx. Right? This whole thing. Okay. Let's go to the next step. So in normally in HSC board, they do ask, in some boards they do ask the proof of this. So you can use the UV rule and get the proof. So x into root of a square minus x square minus, now we'll manipulate this part. So what I'll do is I'll write here a square minus x square bracket minus a square. So I have not changed the sum. A square and minus a square gets cancelled. You have minus x square, and down you have root of a square minus x square dx. Now let's separate this. See, we have v. See this v shape. So I'll separate it. So when you separate, you'll have, so if I separate this, I'll get integration of, so this, see, this is a square minus x square upon root of a square minus x square. So this is raised to 1 and this is raised to half. So 1 minus half is half. So this is a root of a square minus x square dx, right? I'll just separate the entire thing, and this minus, this becomes plus. So you'll have plus a square upon root of a square minus x square dx, right? So let's take the integration sign here. So we just separated everything. Okay. Now, now if you look at this carefully, this part, this is actually the original question. So this is actually I, and here you already have one I. So this I will come here. So this will become I plus I, 2I, right? So you'll have 2I is equal to x into root of a square minus x square plus a square. Now this is the formula which you have done earlier. 1 upon root of a square minus x square is sine inverse x by a, and you will get a concept of integration. Let's say it's c1. Okay, now you take this 2 down, so you have I is equal to x by 2 root of a square minus x square plus a square by 2 sine inverse x by a plus c1 by 2. So we got the final formula. So now let's write down the final formula and write the other two formulas as well. So the first formula was, so C1 upon 2 you can write as C. So the first formula we got, that is integration of root of a square minus x square dx is equal to x by 2 square root of a square minus x square plus a square by 2 sine inverse x by a plus c. This is the first one. The second one is, so the only thing is the formulas are a bit lengthy, little difficult to remember and not very easy to derive. It will take time. So in case you forget the formula in exam, it will take time to derive. So for root of x square plus a square, if you use the UV rule, in that case you will get this answer, right? So you can try using UV rule and solve. It's all three are derived in the same way. And the last one, the third one, integration of root of x square minus a square dx is equal to x by 2 root of x square minus a square plus, so here you'll have minus, so you have minus. So it's always a good practice to derive the formulas, because if you derive it, then you tend to remember it more. Okay, so even if they don't ask you to derive, you should derive it once in a while, so just to remember the formula. So these are the three formulas, and let's use these three formulas, okay, in the sums. So let's start off with the first question based on this type. So let's take a question which says find integration of cos x into square root of 36 minus sine square x. So this is not directly, it's not the form which we want. So we'll try and manipulate. So I can clearly see sine x and cos x. So what I can do is I can put sine x is equal to t. You take derivative, you get cos x dx is equal to dt. So this is taken care of, cos x dx, right? Cos x dx. So cos x dx is dt. So my integration will become integration of root of 6 square minus sine x is t. So t x t square dot dt. And now you get the formula. This is a square minus x square. Now I'll just apply the formula. So the formula is x by 2, so t by 2, so everything is in t, so t by 2 6 square minus t square plus 6 square by 2 sine inverse t by 6 plus c. And now you can resubstitute, so you'll just put the values. So for t you'll put sine x, so sine x by 2 root of 6 square minus sine square x plus 36 by 2 sine inverse sine x by 6 plus c. I get the answer. So you can just directly, these are just direct sums. You can apply the formula. See, this type is also used in this type of integration. So sometimes you'll get a question this way. You'll get a linear equation of the form px plus q, and then you will have a square root which will have a quadratic. So you'll have ax square plus bx plus c. So if the integration is of this type, then what you'll do is you'll write the linear equation in this form. You'll write px plus q is equal to a into derivative of the quadratic plus b, and then you'll find the values of a and b, and then you can solve the question. So let's try one of those questions. So let's say the question is, you have integration of 3x minus 2 square root of x square plus x plus 1 dx. So let's say this is a question. So what I'll do is I'll put linear. So 3x minus 2 is equal to a into derivative of this, so that is 2x plus 1 plus b. Now let's separate it. So see, let's equate the coefficient. So coefficient of x is 3. 3 is equal to 2a. So I get the value of a. A is equal to 3 by 2. Similarly, the other constant, which is minus 2, and minus 2 is equal to a plus b. You put the value of a and you'll get the value of b, which is minus 7 by 2. So I get the value of a and b. So now once you have these values, you can solve this integration. So what I'll do is I'll write integration is equal to, so once we have the values of a and b, I can write the integration. So integration is, instead of that linear equation, I'll write 3 by 2 derivative of the quadratic, which is 2x plus 1 plus b, which is minus 7 by 2. This is the linear equation. Instead of this, I'll write this integration of, and here you'll have root of x square plus x plus 1 dx. Now you can multiply this, and what you'll get is, you'll get 3 by 2, I'll take outside, integration of 2x plus 1 square root of x square plus x plus 1 dx minus 7 by 2 integration of root of x square plus x plus 1 dx. Now let's understand why we did this. So see, this is divided into two parts now. The sum gets divided into two parts. The first part is this one, this part. Now see, this is the derivative of this one, right? So if I just solve this part first, this part, okay, so I can put x square plus x plus 1 is equal to t. So I have 2x plus 1 dx is equal to dt, right? So once I do this, so let's say this is I1 and this is I2. So I'm solving I1. So if I'm solving I1, I'll write I1 is equal to, so I1 is equal to, this will be integration of, so 3 by 2, I can write here 3 by 2 integration of, so 2x plus 1 dx is dt, and this is root t, so root t dt. That's it. Now you can just integrate this. So t, root t is t raised to half, so this will eventually be 3 by 2, this will be t half plus 1, which is 3 by 2 upon 3 by 2, so this gets cancelled, plus c1. So we got I1. So I1 is what? I1 is t 3 by 2, t raised to 3 by 2, which is x square plus x plus 1 raised to 3 by 2 plus c1. So we got the answer for I1, right? Now we have to take care of I2. For I2, what I'll do is I'll convert this into a perfect square, right? So we know how to make a perfect square, right? So we have x square, the coefficient of x is 1, so you divide by 2. So if you divide by 2, it will become 1 by 2, and you square it, so it will become 1 by 4. So x square plus x plus 1 by 4 plus 1 minus 1 by 4, right? So this will be actually x plus 1 by 2 the whole square plus, and this will be 3 by 4, right? So now we have made this a perfect square. So my I2 will be, so I2 is 7 by 2 integration square root of x plus half the whole square plus root 3 by 2 the whole square. So this is square root of x square plus a square. So now we'll just apply the formula. So that is 7 by 2 will be outside. So the what is the formula? The formula is x by 2. So x here is x plus half. So I'll write 1 by 2 x plus half. Then you have root of x square minus x square plus a square. So here you'll have root of x square plus x plus 1. Then you will have plus a square by 2. So a square by 2. So a square is root 3 by 2, the square. So that will be 3 by 4 by 2. And then you have log. And inside log, you'll have log of x plus root of x square plus a square. So x is x plus half plus root of x square plus x plus 1 plus c2. And then you can combine both of them, because this is I1 and this is I2. So I can write the final answer as I is equal to I1 minus I2. And you can just combine both these C's and you can just write a final C. So you get the final answer. Okay. So hope you enjoyed this video, and in the next lecture we'll do partial fractions, which is the most important part of integration. Till that time, take care. Bye bye.